Hi, everyone. Welcome. My name is Anna, and we're going to wait for people to hop on into the call here. But while we are waiting to get started, if you could introduce yourself in chat, introduce with your name and where you're dialing in from. And if you want to share what your data goals are, that would be great too. Hello, Visath. Welcome. Hi, David. Welcome to the call. All right, lots of people chiming in now. Hello, Mohammed. Hello, Lucy. Hello, Mihovil from Croatia. I'm dialing in from California in the US. We're having very warm weather. Hello from Indiana. Hello, Jackie, welcome. And Glory, welcome. Yeah, we have people dialing in from all over the world, which is really wonderful to see. All right, we'll give it another 30 seconds or so, but I do encourage, if you haven't done so already, to introduce yourself in chat, your name and where you're dialing in from. And yes, we will get started very soon. Hello, Mohammed from Egypt, and Moses from Birmingham, and Sunny. And Mihovil says your goal is to learn some new concepts in data analysis as you're a beginner in the field. Welcome to a delightful field. Glad you're here. All right, I see someone's raised their hand. If you do have questions for me, if you could use the Q&A box, I will answer questions related to the project we're doing at the end of the webinar. And if you have questions more so about any of the data quest ins and out, there are a few of my colleagues who are on the call who can help you out too. All right, so we will go ahead and get started. And as we do, we have a poll. Just because I'm curious, I can go ahead and get that launched for us. So I have two questions for everybody. The first one is, what is your experience level with data projects? From a complete beginner all the way to, you've won Kaggle competitions and you could probably teach me a thing or two. And the second question is, have you attended a DataQuest data lab or project lab before? Because we've done a couple of these, and I have some cool tips and tricks that I will cater to depending on our audience. All right, I'll leave this up for a few more minutes, and as we do, I will introduce myself. So who am I? My name is Anna Strahl. Hello, and I am a senior course developer here at DataQuest. And I've been doing this at DataQuest for 2 years officially. Today is my DataQuest anniversary, so that's fun. And before I worked for DataQuest, I began my career as a high school math teacher, and I did that for 8 years, and I really loved the teaching aspect. But I did transition into the data world by teaching myself with platforms, including DataQuest, actually. And I worked as a data analyst for 3 years for a few different organizations before I landed here, where I get to blend my love of teaching with my love of data. So it really is the perfect fit for me. So if you are teaching yourself data skills, I did it, and so can you. All right, so looks like most people have answered the poll. Let's take a look at results. Okay, so project experience level, it looks like the majority of folks are either complete beginners or have done a couple of projects. So this is a great project to work on because a lot of the skills are transferable to any level of data project. We'll go over some basics. We'll see some really cool data visualization techniques. And if you have done several projects already, hopefully there's some things here for you as well. And as far as Data Quest Project Lab attendance goes, most people are brand new to the project lab, so welcome. We are doing this regularly, so keep an eye on your email for future project lab invites. And if you're back for another one, welcome back. Glad to have you here. So because the majority of people are new to project webinars, I have a couple things I will share as we go. But before we get started, I want to make sure this is the right webinar fit for you, because an hour of your time is very valuable. And of course, I would love everybody to stay. But oh, happy second work anniversary. Thank you, Meenakshi. Hopefully I'm saying that name right. Oh, here we are. So to get the most value out of today's webinar, you should feel pretty fluent in basic Python skills like lists, dictionaries, for loops, and conditional logic. If these are something you're still working on, you can definitely get value out of today's work, but it might take a little bit longer to process some of the more advanced concepts. And you should have some familiarity with Pandas and Matplotlib libraries for Python. But if you don't, you can still follow along. There just might be a few functions and methods that are confusing. So I see a couple of Q&As coming in about recording. Yes, this session is being recorded and it will be shared with you tomorrow. So if you have to leave early or you want to revisit any of the concepts that we discuss, oh, I'm sorry, my cat is in the background. If you hear her, she's really excited about data too. So yes, it will be recorded and you have access to it starting tomorrow. So now that we've talked about me and we've talked about you, let's talk about today's agenda. So first, we're going to introduce the project. What is it that we're going to be doing? Then we're going to be doing some brief data exploration, looking at our data sets, doing a little bit of data cleaning, but the majority of our time will be spent visualizing data and looking at some summary statistics. And at the very end, I'm going to talk about how you can share your project, get feedback, and we'll end with Q&A. And as a reminder for Q&A, if you have questions for me, please use the Q&A box instead of the chat box to ask those. And I will save most questions for the end and kind of go through everything all at once. Okay, so what is our project brief? So in October of 2015, there was a data journalist, which sounds like a really cool career, right? Named Walt Hickey, who analyzed movie ratings and found that a website, Fandango, which is a movie ticket and movie rating website, he found that Fandango was inflating the rating system. And this was biased and dishonest because Fandango sold tickets. So the hypothesis was that they were inflating ratings to encourage people to go see movies and encourage people to buy tickets on their platform. So when they were called out on this, did they correct the error of their ways? And that's what we're going to be looking at. Is this live? Yes, it is live. So we're going to be comparing some data sets from before Walt Hickey's investigative data journalism dropped and after, because Fandango did say after the journalism piece was published, Fandango said that it was a rounding error on their site and they would correct it. Whether we believe them or not, I'll leave that to you to decide. And I do see some raised hands. If you have questions, please use the Q&A box. And now let's hop into the platform. So I believe one of my colleagues is going to share links with you right now to help you get to everything you need to follow along with this project if you want to do so. If you just want to sit and listen, that's cool too. So the link that was just shared will give you everything you need in a nice little article chunk. And if you click on the project link, you'll land on a page like is presented on my screen right now. And your screen might look a little different depending on how you've decided to slide your text section versus your Jupyter Lab section. But because I am going to be talking about the learning material, I'm going to slide it all the way over and really focus on our Jupyter Lab environment. So the first thing we're going to be doing, and I'm going to be referencing my side screen here and copying and pasting some code over just to save time. This is the second webinar, Prakash. Yeah, second webinar. And if you're new to Jupyter, that's the environment this is in. There are two environments. This is Jupyter Lab, and Jupyter Lab is a slightly more updated version of Jupyter Notebook, which you may have seen before. And to navigate here, the basics.ipynb file is where we're going to be doing our analysis. There are also a couple of CSV files that if we double click, you can see these here, and you can also download these. If you right click, you should see an option to download. And you can use Google Colab. You can use a local instance of Jupyter if you prefer, because the data files you need are available. All right, so starting with our Jupyter notebook here. Oh, one more thing to navigate to. If you would like to see the solution, that is available here as mission 288 solutions.ipynb. But we don't need that because I'm going to walk you through most of the solution here. And now that we've navigated through the files, I'm going to collapse this side panel to give us a little bit more room. Let's jump in. So the first thing I always recommend is to title your work, and I'm going to use a markdown cell. A markdown cell is a way to render text. This hashtag or pound symbol here will render this as a level 1 header, and we can see it gives us pretty large text. I see Swetha says, where can you download the data file from? So within the project page here, if you look at the CSV files, I'll expand this for a second. There's two CSV files. Right click, and there's a download option, and it should start a download right away. So now that we have a title, we're going to go ahead and start with our datasets by importing Pandas as PD. And if Pandas is new to you, it is a very common, very popular data library in Python. And PD is the common abbreviation that we use just so we don't have to type out Pandas every time we want to reference it. So now we have two data sets, and I called them prior and after. I guess I could have called it before and after, but we're here now. And prior is going to be the data that was prior to Walt Hickey's data journalism piece. So these should show us inflated Fandango ratings. And after is the data set that occurs after Hickey's journalism piece dropped. So we are curious to see if the ratings are different. And we're going to go ahead and run this cell. And if you're new to Jupyter, Shift Enter is a shortcut to run that. And as in any data project, investigating a brief snippet of the code is very valuable, or not the code, the data set. So here we are looking at the head or the first 5 rows of the prior data set. And we can see that there's film, Rotten Tomatoes users, Metacritic, there's a bunch of columns here. And we're not going to need all of these columns because we are specifically focusing on Fandango in this investigation. So we will be trimming a lot of these columns out. But before we do that, let's continue exploring. We could look at prior.info if we wanted to get a better snapshot of the data types, all of the column names, and the total number of columns and entries. So a relatively small data set, but going to suit our needs just fine. And now let's look at the after data set. And we notice a few things right away. First of all, the title names are different, or the column names are different. So instead of film in all caps, it's movie. And we have a year column. We do have some extra things like Metascore, IMDb that we're not going to need, but there are fewer columns in this data set as well. And we can confirm that by looking at info. And so this one has 15 columns, but it does have slightly more entries. But it's not like our two data set sizes are comparable, so it will work for our analysis. So one issue that we can see with our prior data set is if we look at our columns here, there isn't currently a specific column for the year that the film was released. And because we want to ensure that we're looking at movies that were released prior to the data journalism, the year is pretty important. We can see the year is included within the film title. So what we're going to do oh, I realize I just missed a step, I'm sorry. Before we get to that, I'm going to back up because we don't need to clean the entire data set. We are going to first remove columns that we don't need. And here's how we're going to do that. We are going to reassign our shortened data back to the same variable name. However, in order to do that, we're going to use the .copy function. And this will create a copy of our original data set and avoid a setting with copy warning. And if you don't include this, usually it's fine, but occasionally it can lead to issues with data frames getting modified when you're not expecting them to. So it's always a really good practice to add .copy to the end. And yes, both are called prior, and that's completely okay because we're using this .copy here. And so what we're doing is we are taking the original data frame, and within it, we are specifying a list of columns that we want. And we're doing the same thing for our after data frame. And now if we take a brief peek at the head of the data frames, we can see they're much shorter. We're only looking at Fandango related columns. And same thing with after here. And if you were to present this in a portfolio, I would recommend cleaning up your notebook by deleting cells like this. They're not necessary for the final analysis. Yeah, but for a kind of learning project or a project you are sharing with people to get feedback on, this is completely okay to keep. So now that we have our data sets, we can return to the concept of the year being embedded within the title name. And to take care of it, we're going to extract the year using a string method. So what we're going to do here is we do notice that it's consistently stored at the end of each movie title name. So to reference specifically the year, we're going to use some negative indexing, where we're going to first start with the -5th element and go to the -1st element. So we're avoiding the parentheses because we don't need those. And we're going to save this into a new column named year. So if we run this now, we have the exact same data set as before, except now we have a new column named year at the end. And the placement of year doesn't matter because I'm saying this for my past self, like I would have really wanted year to be right after the title. You could do a lot of maneuvering and manipulation to make that happen, but it's not necessary for the analysis. So we're going to continue. So now that we've extracted the year, we want to ensure our data is in the date range we want. And to do this, we're going to look at 1 year in the prior data set and 1 year in the after data set, just so that we're kind of trying to compare apples to apples as much as possible. So we want to look at the value counts. And this is a Pandas method that will look at all the distinct values in a particular column and count how many instances of it there are. And we can see that there are 129 instances of 2015, but there are 17 instances of 2014. So we're going to want to remove those. We have to be careful though, because remember we extracted using strings, and it was originally part of a string. So if we look at the data types right now, and here is a Pandas method for this, dtypes, we can see the year is stored as an object. It's not stored as an int, it's not stored as a float. So when we want to filter it out, if we try to reference it as a number, it's not going to work. And could we convert it to an integer or a float first? Yeah, we could. But again, it's not necessary. So, for computer memory and calculation computation, we're just going to leave it how it is for now. And how we're going to do this is a small filter. And in this filter, we are saying we want to look at where the year equals the string of 2015. And this will pull just that snippet of the prior data set. And once again, we're going to use the .copy function, but we are applying it or storing it to a new variable name. And someone in chat was asking about, are we storing it to the same variable? Before we were, because it was the same set of data. But now we have fundamentally removed a large portion of the data, all of the 2014 instances. So we are specifying now that it is Fandango only in the year 2015. And if we verify the value counts, we see we are left with just 2015. So we are going to repeat this now for our after data set by first investigating the value counts. And we can see once again, we have 2 years worth of data. We have 2016 and 2017. So we're going to remove 2017 because there are fewer instances and it is further away from the Fandango journalism. So it's, not going to give us as clear of an after picture. But let's look at our data types. So notice here that the year is stored as an integer because the original data set, I'm going to scroll back up for a second here. The very original data set of after had a year column already specified. And so when we read in the CSV file, Pandas interpreted this as an integer correctly. And I see everyone helping each other out in chat. That's awesome. Thank you. I love the collaboration and community. So because it is an integer, when we filter out columns, notice that we are specifying 2016 as an integer and not a string this time. But otherwise, it is the same type of code as before. So when we check now, we are left just with 2016. So our data is clean. Woo. Now we're ready to visualize. And to visualize, one of the most common tools to use with Python is matplotlib.pyplot. And just like we very commonly read in Pandas as PD, we import matplotlib.pyplot as PLT. We are also going to use one function from NumPy called arrange. And if you've used NumPy before, we are not importing NumPy as NP, which is traditional. Instead, we are directly importing one of the functions. And this just makes our code a little cleaner because we're not using NumPy in any other instances. So we don't need to be able to reference multiple things. Next line here, this is how we can render charts within Jupyter Notebook. If you're using a regular Python file, .py, you won't need this. You'll run into other problems, but this line in particular is how we can have charts after each code cell. We have a chart coding in. And then finally, I am setting a style. This is where you can have some flexibility and creativity depending on what you find most visually pleasing. I'm choosing to use a pre-built style here called Tableau Colorblind 10. And I like this styling because it is colorblind accessible, meaning that none of the colors that will render in graphics will appear the same color for people who are colorblind, which could be a problem if you have, a shade of red and a shade of green and they look identical to someone. So it's set, it's ready to use, but if you want, you can set your own style. And there is a method available to check out all of the stylings. So if we run this plt.style.available, notice that there is no set of parentheses here because it's not a function. A large list will pop up. And if you have peeked at the provided solution in this project, you'll notice that it actually uses this one, 538, which, to be fair, is a very, very lovely styling, and we will be using it later in this project. So now that we've set our styling, we're going to create our first plot. And I'm going to pause before I put the code up because, in my opinion, this plot is a little controversial. We're going to use a kernel density plot. And this, in my opinion, is controversial because we're not working with a truly continuous data set. Star ratings are on a scale of 1 to 5, and you can have half stars. And you can aggregate to have, an average of 4.3 stars. So on that aspect, it is continuous. But in the graph I'm about to show, it's a little misleading. So I'm going to explain it before I render it. First, we are pulling out just the star ratings from each data set. In our 2015 data set, it's called Fandango _stars. And in our 2016 data set, it's simply called Fandango. We are going to plot this. And then here is the kernel density estimate plot, KDE. And we're including labels and the legend. Because we haven't called PLT show yet, these will render on the same chart. So a couple parameters here, we're adding a title, we're adding labels, and we are using that NumPy arrange method here just to set the ticks on our x-axis to specify 0, 0.5 stars, 1 star, 1.5 stars. Otherwise, the plot will kind of make its best estimate as to what the x-axis should look like. Let that run. And here's the plot that results. And note that if you did choose a different styling, your colors will look different here. So here's why I think KDE is a little misleading. Look at these dips. These dips are KDE trying to navigate from 1-star rating to the next and not being sure what's in between. But our data set doesn't actually have these dips. What this is good for is exploring the data visually. And if you were to include this in a presentation for a stakeholder, you could include this graph, but I would advise you to explain why you're including it and that the dips aren't actually represented in the data. But what it is good for is visualizing these shapes, and we can tell very quickly that both graphs, the 2015 and 2016, are left skewed. But the 2015 data set appears to be more left skewed than 2016. I am going to show you in a moment how we can represent a more accurate version of this distribution with a bar chart, but it's a little more involved. So we're just going to hold on to that for a second. And the benefit of this is having a really nice visual that very easily renders into one graph. So that's why it's included in the project and why I chose to keep it in my presentation. It is a very cool graph to look at. Just there are a few pitfalls to be aware of. And just because it's a data quest, we get bugs sometimes reported to us, and sometimes they're valid and sometimes they're not. Our lesson on skew, we very commonly get bugs saying that we made a typo, saying that we meant right skew when we meant left skew. And here I specifically said left skew, and this is accurate because skew refers to the tail, and the tail is on the left, meaning that this is left skewed. It seems a little backwards. When I taught this to middle schoolers, they thought I was wrong too, but I promise this is left skewed. So there is skew here, and I think in chat I saw Antonio say that maybe 2015 movies were better. Maybe they were better. And that is not something that we could or could not discount from this analysis. You are 100% correct. So if we wanted to truly reach a conclusion we felt very sound about here, we would need more data. We would. But unfortunately, this is the data we have, and we are doing a very quick check of Fandango to see if maybe they have ranked their movies more accurately. And in the next steps of this project, which I'll talk about, that is one of the next steps that you could 100% investigate. So we can see that 2016 is slightly less high ratings, but we want to look at some frequencies to give more numbers to this visual, especially because the visual is, a little iffy. So to do that, we are going to look at value counts, just like we did earlier when we were looking at the years and filtering out years. But this time we are going to normalize. And what normalizing does is it gives us a fraction of how many times that count appears out of all of the counts. And multiplying it times 100 will give us a percentage. So this should give us a pretty good representation of the percentages of stars for each data set. And this print statement is just giving us kind of a quasi header within the code render. That's why that's there. So we can see 2015 confirms the KDE plot that 4.5 stars by far has the largest proportion of the data, whereas the 2016 data set, not quite as much. Instead, the highest proportion has dropped down a bit to 4 stars. So far looking like maybe Fandango did change their star rating, or maybe 2016 was a terrible year for movies. Not sure. But here's where we can start to make a better chart than the KDE graph that you can feel confident sharing with end users. But here's why I showed the KDE chart first. It's a lot more work. So the first thing we need to do in order to get a bar chart, I'll render this first actually. So we get this really nice looking bar chart with 2015 and 2016 bars side by side on the same chart. But in order to do this, we first needed to create our counts, our value counts, our normalized value counts. And then we need to create a data frame from our value counts. Then we can take that data frame and plot it. So not a ton of more steps, but if we're looking for a very quick visualization, the KDE was a lot cleaner. We didn't have to normalize, we didn't have to value count, we didn't have to create a data frame. And if I'm being honest, the KDE does show the distributions slightly better in my opinion. Let's compare. So we have our bar chart versus our KDE chart. And the shape on the KDE is easier to read. But we can see we don't have those weird dips on this one because they don't exist in the data set. So this is another representation of the data looking at our normalized value counts. And the final thing we're going to do is we are going to give a little bit more concrete numbers to the statistics we're seeing. And those are called summary statistics, our mean, median, and mode. So I'm going to copy a big cell here, but we'll talk about it for a minute. And the good news is all of this code is very similar, each line here. All we're changing is the method we're using at the end. So we are doing, we're creating a new variable and we're specifying which summary statistic we are using and which year it is applied to. So to find the mean of our 2015 data, we are looking just at the star column and calling the mean method. Then we do the same thing for 2016. The space here is just to visually break up which summary statistic we are using. And then we're doing the same thing with our median. Now you'll notice mode is a little different. And in fact, I am going to show you why in a cell above this. By the way, the shortcut for adding a cell above, you click on the outside of your coding cell, and if you type A, it'll create a cell above. To delete a cell, if you click D twice, it'll delete it. Okay, so if we look at mode without specifying any like index reference, you'll see that we get two numbers. And if we look at the type of this, it's actually stored as a series, which is a little different. The mean, if we look at that, the mean is stored as a regular old float number. So is median, but mode is a little different, which is why we need to specify this at the end. So we are looking at the first element in a series. So we don't need this delete it with DD. And then we are creating another new data frame. This time we are initializing it as an empty data frame. Then we are creating a new column within our empty data frame called 2015. And we are including our new variables representing each summary statistic. Doing the same thing for our 2016 data. It is very important here to be mindful of the order. Notice that each is mean first, then median, then mode. And when we set the index, we are doing that same order. If we don't have the same order here, our data is useless because to our audience, the numbers won't align. So we're going to go ahead and render this. And one cool thing about Jupyter, if it is a newer tool to you, you don't need to specify a print statement. If it is the last line of a coding cell, it will automatically render. I think that's true for most things. If you run into an example where that's not true, let me know. I'm curious. And then we get this really beautiful little graph, technically a data frame. I see Glory in chat asked me to re-explain index. Sure, since we're right here. So .index sets the index of our data frame. So summary is the name of our data frame. .index will set it to whatever we specify here. If we want to see what happens if we comment that out and don't render it, you can see our index defaults to, just regular Python indexing 0, 1, 2, which isn't terrible, but to make it a little bit more informative for our audience, we can specify the index with a list. And if we, I don't know, add more text, you can see that that's how it's rendering there. Okay, so now we are going to plot our summary statistic data frame. And this is very similar to the plot we made up here with our normalized value counts. So the first thing, I am specifying a different styling here. If you were creating this for a portfolio, I highly recommend keeping a consistent styling. But in my opinion, the 538 styling of this graph is really nice. And I wanted to show you a different styling. If we didn't specify a styling, it would continue to use the styling we specified earlier. But now it's going to pivot to 538. So we are creating a bar chart for our summary data frame. We are adding a title. I don't think I mentioned this earlier, but setting this parameter y equals 1.07 will give us some padding. I'll render it so we can see. It gives us a little bit of padding between the title and the actual chart to create some visual space. Then we have our y limit to represent our stars. And here we're using our arrange function again to set ticks at each different star count value. And when I was preparing this presentation, I actually was wondering, like, why are we doing this? And could we instead have a list here that just gives the values 0, 0.5, 1, 1.5, 2, 2.5? Yeah, you could do that. This is just a little more concise. And another thing I learned that I'll share with you is if you have used Python's built-in range function before, this is very similar to that, where you say your starting value, your ending value, that's not included, which is why the 0.1 is here, and then your step. But the reason we can't use Python's built-in range function is that doesn't work with floats. It only works with integers. So we had to use the NumPy version here. We add a label, a legend, and here's our beautiful graph. So one more thing I wanted to talk about before we wrap up for some Q&A. Now is a great time to start adding your Q&A to the Q&A box if you have questions for me. If you added them to chat, chat's been very active, which is great, but I won't necessarily catch your question. So add it to Q&A, please. I want to talk about this parameter in Legend. I didn't know what this parameter was when I started creating this presentation, but you have two options in my opinion. Three options. Option number one, you can look up the function in the Matplotlib documentation. That's what I did. And it will tell you what frame alpha means. Option two, you can experiment. What happens if you change this? Change the value, look at the results, and you can probably make a pretty good guess as to what's happening. And the third option is you can ask an LLM. So if we wanted to, just for demo purposes, let's go ahead and add that in. What does the frame alpha parameter do in plt.legend? Yeah, it controls the transparency of the legend box. So a couple options here if you want to visually see in my presentation what it looks like if we change it. You can see that we start to get kind of a border background on our legend. So you can set that to whatever you want. I think 1 is the highest value. We could experiment. Does 2 do anything differently? So 2 is not a value that we can use here. I'll set it back to 0. And so we have a really beautiful representation of our summary statistics that does seem to show that in 2015, the mode and the mean were much higher than the median, which does back up the left skewed KDE that we started our exploratory visualization with. Whereas the 2016 summary statistics are pretty flat, which shows a more consistent representation of ratings. So can we conclusively say that Fandango changed their ways? No. But is it a really cool piece of data journalism to consider? Yes, 100%. So a couple next steps, because if you do want to include our data quest projects in your portfolio, we encourage you to do that. But to really make your project stand out, we also encourage you to go beyond. So a couple ways that you could continue this project, these are just ideas. If you have your own, explore them. Style your graphs, create some really beautiful visualizations. Can you create this graph within your Jupyter notebook? It is possible. So that could be a cool challenge. Use different movie aggregations. Maybe IMDb also had movie inflation issues, and you could be the next data journalist to uncover some pretty cool stuff. And because this data journalism piece is at this point pretty old, what happens if you look at more recent movie ratings? Fandango has actually sunsetted their 5-star system and has exclusively started using Rotten Tomatoes. So maybe look at Rotten Tomatoes, maybe look at IMDb. Is there an issue with inflation? Is there skew anywhere? Maybe certain kinds of movies are more likely to be inflated than others. These are really interesting questions to ask, and I'm curious. If you are wanting to share your work, which I do encourage, the previous project lab that we did, I went into depth on how to share your work in a GitHub gist, which is a super simple, almost one-click way to get your rendered Jupyter notebook onto the internet. So if you would like to see that, we'll share the link to that recording with you, and the information is towards the end of the recording. And at this point, let's hop into some questions. So friendly reminder that if you have a question, please ask it in Q&A, and I'll start working through those. Okay, so I see Mode asked, most of us are new here, how did we proceed further in data analysis? So I think this is a kind of career question. How do you learn the skills you need to learn? How do you find the career you want to have? We actually have a phenomenal career series going on. Maybe in chat, Nisha or Celeste can share information about that. We have a great speaker scheduled coming up soon. Highly encourage that if you do want to hear more about how do you how do you take your learning and transform it into the career. Jyothi asks whether resources to practice are provided after the session. Yes, everything that I presented is available. We have an email that has gone out, and DataQuest just shared in chat a link that has a very helpful article with lots and lots of valuable resources, many of which I mentioned here. I curated that list of links myself, so I definitely encourage you to browse those and learn something new. Someone asked in Q&A, can you use Google Colab? Yes, you can use Google Colab. Where to store CSV file first to extract the data? So CSVs, oh, I remember I had this issue when I was just starting out working locally. I could not for the life of me get my read CSV to find the CSV file I specified. I know this pain. So the best advice I have is to make sure that you do one of two things. The easiest thing is to store your CSV files in the same folder where your Jupyter Notebook is stored. So if you have a folder called Documents and your notebook is directly there, Documents is where your CSV can go. Otherwise, you can specify the file path, whatever it is. I'll just use a random one here, make sure I don't have any personal information. One moment. Okay, yeah, this is good enough. So something like this, right? This is obviously not the right file for this project. I just copy and pasted what I was working on. But if you were on a Windows machine, my fellow Windows friends, you will want to be very careful about these characters. Windows has a hard time rendering these sometimes. So there's a couple ways you can handle this. You can add R in front, that sometimes solves the problem. You can also do double slash, so only one of them gets read in. And hopefully that saves you some of the headaches I had when I was first starting out with reading files locally. Great question. Okay, Sharaf asks, Excel seems easier and more practical in terms of manipulation of data. Yeah, Excel is awesome. The problem I personally have with Excel for a project like this, and Excel has its merits and is 100% valuable and useful. But what I like about using Python and Pandas for data manipulation is it's repeatable at the click of a button. And everyone can see exactly the steps you took to clean the data. Where in Excel, it's a little bit more of a black box for that. So that is my opinion of the big pro and con difference. And Glory asks, would it have been possible to find only columns with titles containing Fandango? Yeah, that's a really cool idea. So returning to here, where we filtered for columns, you could definitely write a filter here that says, if contains Fandango. I can't, like, on the spot imagine what that particularly would look like. The one thing to be mindful of there is making sure that you do include, other columns with valuable information. All right, Anonymous asks, why do we use the percent matplotlib inline? Good question. Let's find that in my document here. There it is. This is, I believe it's called Jupyter Magic, and it is specifically for Jupyter Notebook and Jupyter Lab. I think it works in Colab too, correct me if I'm wrong, to render graphs. So it may correctly interpret graphs without it, but you could also run into issues. So let's try it out. Okay, so it's working okay for me, but you can see some of the things are just a little more clunky. And to ensure consistency in your rendering, this line is valuable. Okay, the bar chart seems more pleasing. Yeah. That's the one I would use in a presentation. So, but I do like the KDE chart. I do. What is the point, Mark asks, of plotting the summary statistics as a bar chart? I think it, is the point huge? No, but for me at least, it made it much easier, like in a quick glance, to see in the 2015 data, the mode is very different than the median. Whereas in 2016, at one glance, I can see all the bars are about the same height. So for an end user or an audience, it's much quicker to digest a visual than it is a chart, because a lot of people have a fear of numbers, a number aversion. So if you present this to them versus this, one of them's going to sink in more quickly. Why do we not normalize the value counts in KDE? That's an interesting question. KDE is already looking at densities, and value count with normalization it's slightly different, but it's sort of doing the same thing. So it would have been an extra step that we didn't need to take. Oh my gosh, there are so many more questions. So we have a minute, I believe, left in our scheduled webinar time. So I'm going to pause here. If you do need to head out, I want to honor your time and say thanks for coming. If you do want to stick around, I can stick around 10 extra minutes to answer more questions. But I understand if you have a busy life and things to do. So yeah, thank you, everybody. I'm going to go ahead and keep working on questions, but if you need to head out, go ahead. And can we get the presentation after this? Yes, tomorrow it will be shared via email with everybody. All right, so continuing on with questions here. Shiraf asks, do you think generative AI can make your coding much easier? Yeah, I 100% agree. In fact, when I was creating this presentation, I worked with an LLM, generative AI, to help me make a concise graph here. Could I have done it without AI? Sure. Was it quicker with AI? 100%. The one caution that I have about learning specifically with AI is do make sure you understand what's happening. I have asked AI to create code snippets for me before where it's very confidently wrong. And I wouldn't have necessarily spotted what was wrong if I didn't understand how, Python code worked. Okay, Anonymous asks, while creating the year column, so let's scroll back up there. Here. You sliced the column using string -5 to -1. Why was the closing bracket not included in the output due to the use of -1? So this was to account for the parentheses. If we wanted to explore what happens if we set it as 0, actually, we don't even need that, do we? Oh, yes, we do. You can see it's including that ending parentheses because it's going all the way to the end of the string. So in order to cut off that final parentheses, we need to tell it to bump back 1. And now it will not include the parentheses there. Someone asked, do I know any data science hackathons? I don't, although when I was learning, I found a great Python hackathon through Meetup. I joined a couple Python learning groups, and there was a hackathon someone organized, and it was a lot of fun. There was pizza, there were prizes, and some really fun coding. So Meetup is great. I also recommend Kaggle, because they have competitions. They're not hackathons, but how to upload this to GitHub. So I can very quickly demo gists. For repositories, that's a little more in depth that I'm not going to do at this moment. But for a gist, you literally go to, I'll scroll up a little bit, gist.github.com. And then you can drag and drop your file straight into the coding screen. It'll look a little funky. This is what Jupyter notebooks look like on the back end. And when you create your gist, you can do it secret or public, depending on if you want other people to see it. And now look how quick this is. It immediately renders our entire project notebook for others to see. Yeah, gists are great. Okay, Gavish asks, can you explain how do you interpret KDE and how did you conclude it was better than a box plot? Better is, better for me personally, it was better to see the shapes. I can see very easily here that there's kind of this curve shape for both charts, or not charts, both data sets. Whereas for me, this visualization, there is a shape, but it's not quite as obvious for each data set what those curves are. But if you saw the bar chart more easily, awesome, go for it. You just have a little bit more pre-work to do with all of the value counts and creating a data frame before you can actually see that plot. Okay, scrolling through. Mihovel asks, do you have any idea how we could check if there was a bias in the data? Yeah, this is interesting. So these data sets do inherently have a little bit of an issue. I didn't go into depth here in this presentation, but the project on DataQuest platform goes into a little more depth of evaluating whether the data sets are valid or not. So I highly encourage you to check it out there. And I think that comparing the average scores from Fandango to other platforms, because we have that information provided in our beginning data sets. Yeah, is Fandango's average consistently different than averages from other sources? I think that the answer to that question could give you a lot more confidence about whether or not there is bias, if 2015 movies are better, worse, same than another year. So yeah, that's a really good idea. Joshua says, when you print columns, you only see film, Fandango verse, and Fandango difference. So this is probably a debugging thing. It could be that there's a typo in one of your other column names. For example, if we try to render this with a lowercase letter, it's probably not going to work. Yeah, because Fandango lowercase stars doesn't exist. So that's what I would look at for you, Joshua. Decory in chat. Oh, you're welcome. You're very welcome. And I'm glad you enjoyed it. See you next time. Okay, more GitHub questions. Ubada asks, do you recommend using older version of Python inside an environment to avoid packaged incompatibility? Yeah, if you need to use an older version of Python for some reason, setting up like a environment will definitely address those issues. You know, that's its own learning curve, but if that's something you're already comfortable with, yeah, go for it. In fact, I do that locally, especially in both Pandas and NumPy and the Matplotlib for that matter, have all recently rolled out new versions that don't necessarily play nice with older versions of things. So when I need to use new versions specifically, I make sure that I have an environment for those. For this particular project, I don't think there should be any compatibility issues with libraries. But if you do run into that, let me know. I'm curious. Okay, we're at about a minute left. I'm trying to find questions that will be the most valuable to the most people. I see Diana asked, you really enjoyed the meeting. I'm glad. And one more plug, you asked about jobs in data science. We have a really awesome career webinar series happening right now. So check your email and join us for that because we have some phenomenal speakers lined up. And if you didn't get your question asked, join the DataQuest community. And if you want, you can 100% tag me in a post. What's my profile name? Let me see. Anastral. So you can tag me and talk to me there if you have more questions or you're curious about projects. Also share your projects in the community if you do next steps for this one and tag me. I'm curious to see what everyone does. And at this time, we are going to unfortunately have to end, but my final plug. please fill out our feedback survey. It helps me know what went well, what could go better to continue making this project lab series better and better each and every time. All right, and thank you everybody for coming. See you next time. Bye. Oh wait, how do I end the recording? One moment, technical difficulties. Celeste, I think you might need to end it.
I will.
Okay, thanks.
Somebody's asking how to join the community. You can join through your account. Just sign into your account, look for the community link in the bar. When you click that, you'll be auto signed in and you can start using the community. Have a great time, everybody. And yeah, thank you.
All right, bye.